This FreeCAD 1.1 lesson guides you through creating a simple animated piston assembly from the ground up. While the model itself is fairly basic, the main goal is to take you from modeling to assembly along with simulation, whilst giving you essential background knowledge in both the concepts and using FreeCAD. We'll also introduce you to the principles of a common CAD methodology, the top-down modeling approach, how that can be applied to FreeCAD, along with utilizing new features in FreeCAD 1.1, which should make this workflow easier to implement. The top-down approach starts with the overall assembly, before working on the individual parts. One approach to top-down design is to use a master sketch that defines the main structure and how all the components fit together. Individual parts are designed so they reference the master layout. This method helps establish the design intent early, ensuring that all relationships between components are clearly defined. A major advantage of this approach is that any updates made to the master layout automatically flow through the model, updating the connecting parts, saving time and reducing the need for manual adjustment. If you like what you see and you want to donate to the channel, then you can do so via Ko-Fi or Ko-Fi at ko-fi.com/MANG0 or via PayPal at paypal.com/paypalme/DarrenBEstone. I also run a Patreon where you can get early access and additional content, and that's at patreon.com/MangoJellySolutions. Links can be found in the channel header, on the About page, or in the descriptions of these videos. We will first create the following master sketch in the Sketch workbench in FreeCAD. It contains a basic outline of the parts as a cross-section through our assembly from a single viewpoint, the top or the XY plane. If you're already familiar with FreeCAD, you can skip this section of the tutorial and create a single sketch in the Sketcher to capture the geometry and dimensions shown on screen. If not, let's continue to the sketching stage. So we've opened up FreeCAD and I'm going to start a new document. Come over to the drop down and come down to the Sketcher. We'll be designing the part design by using the Sketcher itself to create the master sketch. This means when I create a sketch and we'll place it along the XY plane, hit OK. If we look at the tree view on the model tab, we see the sketch is not inside a container. If we did this in the part design, it will be placed inside a body. This is not needed. Before we start sketching, let's look to the left hand side. In the top we have a drop down, and within here I have the snap to grid unchecked. Next section, we drop down the options in here. I have the alter constraints checked and the alter remove redundant constraints checked. This is important. The first part we're going to sketch is the connection rod or the link arm. Using the slot geometry, left click that, let's place the geometry away from these lines. Left click to add, we get some fields that we can add the dimensions in. We ignore these for the time being and let's move our mouse down. Notice the vertical constraint has kicked in. Left click, everything disappears, but we get the field for the diameter. As we move the mouse to the right, we can add in our slot and left click again. Right click to cancel the tool and use the dimensioning tool. Left click that and I'm going to select this point with dimensioning to the sketch origin. If I don't want to do, let's move down and left click on the other point, which allows us to move the dimension out to the left hand side. Left click again and we can add the dimension in to 110 millimeters. Before we hit enter, you can see the dimensions of our 3D view. If I hit OK, first geometry changes the dimensions to allow our 3D view to fit our geometry. If this doesn't happen, then we have to zoom in or out so we can see the geometry. Let's click on the circle tool, hover over the center point of our arc, so we're coincident to it, click and create the circle. Left click again to drop it. The same with this point down here. And right click to cancel the tool. Make sure these points are actually connected and we can move this from left to right. If we do get separation like this, then we just place the points close to each other, click and highlight those 2 points with a box selection, also known as rubber band selection. And then we can add a coincident constraint. Points are now in red, so they're connected. Let's use the dimensioning tool. Dimension the top arc, click once, click again to drop it. The radius is 10 millimeters, and then select the circle inside. Click once, move the mouse pointer out, click again, and we'll set this one to 7 millimeters for the diameter, and hit OK. Now we need to set this circle the same as our previous one. We just right click and then select the circle. The circle has been selected in the left hand side, and then we can select the other circle. We haven't held down Control when we've done this. This is something called the hungry selection. If I select something else again, it's added to the hungry selection. If I select the same line that's been added, it's removed. You can see that on the left hand side here. Once the two circles have been added, we can use the equals constraint to make them equal. All the time we're doing this, if we look at the sketch edit, we see we have 2 degrees of freedom. That means this can move in 2 degrees. Best practice is we get down to 0 degrees of freedom to make this fully constrained. If we click on the 2 degrees, it shows the whole lot as not being locked down. And we see this when we move the slot. I want to make this slot geometry centered over this point. To do that, we use the hungry selection. Make sure nothing's selected. We can see that in our elements. If it is, just click on some blank space. Click on one point, then the other, then the sketch origin point, and use the symmetry constraint. That will constrain the slot symmetrical to the last point we selected. Look on the left hand side, we're fully constrained, and we've created our first piece of geometry in our master sketch. The next piece we'll add is the piston head. Let's use the rectangle, and this time we'll left click and start moving the mouse to the right, but we'll add the dimensions via the fields on screen. So for the top, this is going to be 60 millimeters. The arrow has gone red. This means if I move the mouse, I can only move it up and down. I want to keep both sides the same. If I wanted to add a measurement to the left hand side, then I use the tab key. The lock is added to the top measurement, locking that in. I can still move the mouse, or I can type in a measurement. I don't need one. Left click, 60 millimeters has been added, and we'll right click to cancel the tool, and using the hungry selection, selecting the top, side measurement, we'll make those equal. At any time, we can come in and double click any of the data measurements and change them to what we like. Let's cancel out. Again, I want to make this centered. This time, click to make sure nothing's selected and take the left point and the right point, then use the vertical axis and create a symmetry constraint. Symmetrical to the axis, and you notice we have 1 degree of freedom, so we can only move along the y-axis. That sets some distance away from this point to the sketch origin. Make sure we have nothing selected, just click on some blank space, click on the dimensioning tool. The bottom point we're going to click. We don't have to click on the sketch origin, it's automatically added, and we move the mouse until we get the vertical measurement. Click to add and set this one to 20 millimeters. We're fully constrained. All parts of our geometry are in green. Let's right click and move the measurements so we can see them. Let's add some arcs now. There are 2 main arcs. We drop this down, the arc from center point and the arc from 3 points. Arc from center, and we'll attach directly to the vertical axis. Look towards the mouse pointer. We get the point on object constraint. Left click once, we've added the center point. Move to the left, we get the circle visualization. Go around about 25 millimeters. Left click again, disappears. Then we can change the angle to come all the way over to create an arc of 180 degrees. Let's add another arc. This time, let's experiment with the arc from 3 points. I'm going to zoom out a little and pan the 3D view upwards. For me, I'm using touchpad, which is holding down the shift and moving the mouse. And if we forget, we just hover over the button on the bottom, showing us our shortcuts. With the arc by 3 points, it's exactly that. We have to define the start point of the arc. left click once, move across, click to define the end point of the arc, and then move the mouse to create the curvature of the arc. We'll drop this one, making sure we're not touching any of the axes. The trouble with this one is that we haven't attached it to the vertical axis. Let's zoom in. The arc point is here, and I'm going to attach it to this point here. Make sure nothing's selected by clicking in some blank space. Click the point, then the second point, and use the coincident constraint. Adjust the size of the arc by moving the arc towards its center point. Let's add some dimensions using the dimensioning tool. Select the top arc and set this to a radius of 25. Tool is still active. Use the bottom arc and set this to a radius of 17. We could right click to cancel the tool, but I'm going to use the line tool, and if I click that, the tool is automatically activated. Hover over the point of our arc and the point of our bottom arc, coincident to those points to add a line, and the same on the other side. Once those are added, right click to cancel, and we'll create tangency between the line, selecting it, making sure it's selected on the left hand side, and the top arc. Select the tangent constraint and hit OK. For a quicker selection, we can select the tool first, then select the line and the arc, hit those tangent, OK, and the same on the other side. The arc, then the line, make those tangent. And do the same on the right. Hit OK. Still got 1 degree of freedom. Right click to cancel the tool, and we can move this, as you can see, up and down at the moment. Let's use the dimensioning tool. The arc center point here, click on that, and come down and select the other arc center point or the circle center point. Click again and set this to 30 millimeters. We've fully constrained once more, and we created the counterweight. We have 3 parts so far: piston head, the link arm, and the counterweight. Let's create the mount. Right click to make sure our tools are cancelled. And for this, we use another slot geometry. Add that in. Right click to cancel the tool. We'll take the arc of the slot geometry, click on it, and hit delete on the keyboard. This is now open, known as an open wire. Let's take the line, hover over the left point, and add the line. Coincident constraint has been added and vertical constraint, but we can see the vertical constraint has failed. So I'm going to right click, yours might be added, and we just come up, click on the vertical horizontal and add that constraint in. Right click to cancel and add a circle coincident to this point. Right click to cancel again, and we start adding some dimensions. First of all, the circle, we're going to make that the same as this circle, making sure both of those are selected, and hit the equals constraint. We also can make the radius of the arcs the same. Arc here, and say this arc, make those equal. And you might find that you haven't got some constraints in here, so I haven't got the vertical constraint. So select that and use the tool to add the vertical constraint. Now we'll set the length of one of these sides using the dimensioning tool to 60 millimeters. Right click to cancel the tool, and we'll drag this into position about here and zoom in. Everything might look a bit cluttered. We'll take this point and the vertical axis. Use a coincident constraint, which will place a point on object constraint against the vertical. And this circle we'll use as the rotational point. So when the animation is running, it will be rotating around this circle. We'll place it about here. We can adjust this later. We'll take these 2 points, and those 2 points, set a distance. We'll set this to 15 millimeters. Hit enter. We're all fully constrained, and we have our master sketch. Hit close, and we have our first sketch. Right click and rename to master sketch and hit enter. Let's save our parts, file, save as, select the directory you want, and we can call this our parts. We can now progress to the next stage. Each part that we build will go through the same process. We start by creating a new body in the project and make sure it's active. When a body is active, FreeCAD directs all new operations to that specific body. We give the body a clear descriptive name that reflects the part we're modeling. This helps keep the project organized and allows us to easily identify each part when we add them to the assembly from the list. We select the master sketch, then create a SubShapeBinder. Sketches that exist outside the body can't be directly referenced from within. A binder acts as a bridge by exposing the necessary geometry inside the active body. Once the SubShapeBinder is created inside the body, it can be used like a master sketch. If the master sketch is later modified, the binder will automatically update as well. We create a new sketch, which will be added to the active body and opened. We use the SubShapeBinder to project the geometry from the master sketch. This allows us to define the shape of the part that we're creating based on the overall layout. Note that if the master sketch is visible, it will get in the way when projecting the geometry from the SubShapeBinder, causing the error, "This object belongs to another body, can't link." The error will also show the sketch geometry that is being picked, a sure sign that the master sketch hasn't been hidden to keep it out of the way. Once we import the needed geometry from the master sketch, we add any extra lines, arcs, constraints to complete or refine the part's geometry. We close the sketch and use additive or subtractive operations to create solid features from the sketch. And finally, we continue adding new sketches and repeating the process, referencing geometry through the binder to define and build the remaining features for the part. We're currently in the sketcher. Let's move over to the part design workbench and look back to our model tab. There is nothing selected at the moment, so when we create a body, we just end up with the origin inside. Let's rename our body, and we'll first tackle the link arm. Call this link body and hit enter. For me to use the master sketch inside the body, I need to create that bridge via the SubShapeBinder. So we select the master sketch and then click on the SubShapeBinder. We now get the binder added to the link body. And if we click on the binder, we can see the support is the master sketch. Now we need to hide the master sketch. Click on the eye icon or press the spacebar to toggle the visibility. The binder we need to select, and we can see that the make face is checked. Let's uncheck that. And now we just have the edges. Next step is to create our sketch. It gets added to the active body, and we want to place it along the same plane of our ShapeBinder or master sketch. Click the XY plane, and we can see the ShapeBinder behind the sketch. We can come over to the model and click on the binder, come down to the view tab, and increase the line width for the binder by 3. This just makes it easier to demonstrate. You can see what I'm doing. This process will be repeated for each part. We're going to import geometry from the binder. Now from FreeCAD 1.1, geometry can be imported as defining or construction geometry. In previous versions, we just had construction geometry. This is where we have to be careful. There is a setting. We go to Edit, Preferences, come down to Sketcher, look at General. On the right hand side, we have the option always add external geometry as construction. If this is checked, we'll hit OK. When we use the projection tools, the external projection or the external intersection, we'll be using external projection. If we bring in, say, this part of the geometry, it comes in as a dashed line. This is construction geometry. I can right click and come to the Task tab and close. You can see we haven't got any sketch geometry within. We've just got the binder showing. I double click that sketch and select that imported geometry and then use toggle construction geometry, then it converts it to defining geometry. So when I close, let's hide the binder to make it easier to see, we see we have the geometry. So let's come back in and delete that. When we have that option unchecked, edit preferences, back to the sketch in general and uncheck the option. Okay. Depending on the state of these tools, whether they're in defining geometry mode or construction geometry mode, the import will import as that mode. So at the moment you can see these are all blue, so we're in construction geometry. If we swap the mode, click this side, this is now defining geometry. And if we hit close, we can see that only one side has been imported. And the other side, this top piece of geometry, click on that. We need to select the tool again to make it defining geometry. Let's come back to that sketch and delete the two imported sides. I'm interested in this link to this geometry here. We'll use the tool for external projection. Click that and import all the edges and circle of the link geometry. Just right click to cancel the tool. When we create parts, this point will be the transform or the pivot point. Let's hit close. Now we have our sketch. If the binder is visible, just use the eye icon to hide it. Now we can take the sketch and run an operation against it. The pad. We've padded straight upwards by 10 millimeters. Now totally down to choice of where we want to pad this. Going straight up is okay. But let's change this to symmetrical. So we're symmetrical to the plane and hit OK. If I transform this link body by right clicking on it and coming down to transform, notice our pivot / transform point is in the middle of the object. Just hit OK. So how does FreeCAD make that relation between the transformation point and the origin that we're modeling over? It's all to do with the origin of the containing body. Let's show the origin. You can see that we have a center point here, the origin of the body itself. New sketches are created in line with that origin. So if we created this pad, sketch of this pad, and this link was over here, then the transformation point will still be at this point. The same happens if we change the attachment offset of the sketch, placing it away from the body origin. I'm just going to hide the origin. When we come to other parts, we'll revisit this because the transform point will be off in space. We've created our first part. Let's repeat this process for the other parts. First, we need to hide the link body by using the eye icon. If you don't have the eye icon, edit preferences, and it will be under the display and the UI. And we have the tree view and the show visibility icon. Or we just use spacebar to toggle the visibility. Now, if we have this visible and we pick part from the 3D view, say press the spacebar to toggle its visibility, what we've actually done is toggle the visibility of the pad, and we haven't hidden the link body. So anything that's visible within here can be shown and the link body is still visible. Hiding the top level link body hides everything from within. We can move to the top level by first clicking on the link body, clicking again, that selects the operation, click once more and you see it move up to the top, and then we can press the spacebar. Make sure nothing's selected and create another body. This one, let's right click and rename, is going to be our counterweight. We follow the same process. Select the master sketch, it's hidden at the moment, that's fine. Create a SubShapeBinder, click on the binder, come down to the data tab, and set the make face, uncheck that. The master sketch is invisible. The counterweight body is active. So when we create a sketch and place it on the same plane as our ShapeBinder, sketch gets placed in the body. Let's just increase line width 3, just so we can see it better. I want to import geometry of this counterweight. Again, use the external projection tool and start importing all the edges, the circle that's connected to the link arm, and the circle that will rotate around. Go to the Task tab and hit Close. Hide the binder. Take the sketch and pad this. Let's use symmetrical and leave it at 10mm and hit OK. Let's hide the counterweight body, collapse it in the tree view, making sure nothing's selected, and create a new body and rename the body to piston head body. Now, if we look back to the master sketch and show it, the piston head, let's click on top and adjust our view. If we look at the origin, show that the origin point is here. So this will be the transformation point, which is disconnected from any volume we create within here. To fix this, I can right click on the piston head, click on transform, and then use the move to other object. If I click on that, then we can transform the body and snap it to parts of the master sketch. So I'm going to use this hole here and click on that. The origin of the body has moved because the body itself has moved. And let's hit OK. So now when we create our sketch, it will be located at this point. Our transformation point won't be disconnected from the piston volume. So let's take the master sketch and create a SubShapeBinder. Take the binder, increase the line width, click on the Data tab, and uncheck Make Face, and hide the master sketch. Now I can make sure that nothing's selected by clicking on some blank space and creating a new sketch on the XY plane. And we're placed at the correct position. Sketch origins aligned with body origin. Using the external projection tool, let's import the left-hand side. And we're going to do something different here. So this is a cross section through the piston head, which will revolve around this axis. I've imported the left-hand side as defining geometry. Now I'm going to import the top. Now I need to set this as construction geometry. I want to use it as a guide. Construction geometry won't show up outside the sketch. We use this tool here. This changes our geometry, so we can see this change into blue. We're now in construction mode. If I import the top line, it becomes dashed. Let's right click to cancel and toggle back defining geometry. If I hit close and hide the binder, you see we only have one piece of geometry on the left hand side. But inside the sketch, we have this dashed geometry. We can attach other geometry to it. I'm going to use the polyline tool, hover over this point here, zoom in slightly and readjust our screen. Hover over this point here, click once for coincident, come across, we get the horizontal constraint, click again, come up, vertical constraint, click once more, and come across, and you'll see a point on object constraint for the vertical axis, and also a horizontal constraint. Click again, that's attached. So now I'm going to come up and attach to this line here. Now, as we move across the line, construction line, you'll notice that we get different constraints. So we've got a symmetrical constraint, we've got a point on object constraint, and as we move towards this point here, a coincident constraint. If we come in and look for the symmetrical constraint and click, we attach to this line symmetrically across here, and can see the symmetrical constraint has been applied. That's come across and attached finally, coincident to the left hand point. We need to right click to cancel the polyline and then right click again to cancel the tool. Let's select this line and this one, make those equal, and we use the dimensioning tool and set a dimension of 3 millimeters and hit OK. Let's close this now. Our binder is hidden and we can see we've got our cross section. If I take the sketch and apply a revolve operation, we see we've revolved around this axis here, the vertical sketch axis. Let's hit OK. Let's just hide the origin. It's still visible. Show the binder. We need to create a hole in this object. Make sure nothing's selected and create a new sketch. We'll place this along the XY plane. The sketch is running through the center of the piston. So there's a tool called the toggle section view. If I click that, this allows us to view inside the object. We're on a new sketch. Let's just zoom in a bit, use the external projection tool and pull in this circle here and then hit close. Let's hide the binder, select the sketch, and this time we'll create a pocket operation and adjust our view to see what's happening. This is removing material in the shape of this profile. If we change the mode to symmetrical, it will remove in 2 directions. And if we change the type, at the moment it's a dimension, to through all, it will pass through any volume that stands in its way. So we have piston head, and now we have a hole going through that. And if we right click on the piston head, go to transform, we can see our pivot point or our transformation point is where we set it. Let's just cancel that. We have one more part to model. So that's collapse the piston head and hide it from view. Make sure nothing's selected and create a new body and rename this body to mount body. Hit enter and we'll show the master sketch. Let's look from the top view and we want to fit this sketch in the 3D view. We can either select it and use the fit selection or use the fit tool. We're looking at this mount here. So if I right click on the mount body and transform, we can see it's going to be attached at this point. So it's going to be out in space. Let's pick one of these circles by using the move to other object and selecting this circle. Let's hit OK, then take the master sketch and then use the SubShapeBinder. The binder's been added to the active body. On the data tab, let's uncheck the make face. And if we wanted to, we'll just increase the line width to around about 3, just to make it easier to see. Remember to hide the master sketch, otherwise it's going to get in the way. Let's create the sketch by making sure nothing's selected and creating a new sketch along the XY plane. Our sketch origin has aligned with the body origin, and now we can import geometry using external projection and pick in the geometry that we want. Pick all the geometry as defining geometry, and let's hit close and hide the binder and use the fit tool again. Let's add slight rotation and take the sketch and use the pad. Length, we're going to set this 15 millimeters and select the mode as symmetrical and hit OK. I want to create a void in here with 10mm walls that our parts fit inside. Select the face and create a new sketch, and we'll import geometry, making sure it's construction geometry. The geometry has turned blue. Now I want to import this point. Make sure we toggle back defining geometry, use the rectangle, place a rectangle within here. Right click to cancel the tool, use the dimensioning tool Take these 2 points, place a dimension of 10 millimeters. OK. And again, take these 2 points and place another dimension, this time along the horizontal, of 10 millimeters. Right click to cancel the tool and take these 2 points and the horizontal axis and use the symmetrical constraint. That set the length of this line using the dimensioning tool. Set the length of 60 millimeters and hit OK. This is the height of this part. I'm just going to place save and set the 60 millimeters to 65. I could import this point here and place this in line, but I want to make sure that I clear the top of this curve. Let's hit close, take the sketch and use a pocket operation. We're pocketing this way through the object and we'll set type through all and hit OK. We've created the void that we need. Now we've created all our parts, we can make them visible. Let's leave the master sketch hidden. Use the fit tool and we can see all our parts here. By using the master sketch along with symmetrical padding and well-placed pivot points, the parts are already aligned and centered. The master sketch also keeps our design intent clear and visible, helping us to stay consistent throughout the process. So for assemblies, FreeCAD offers up its own internal assembly workbench. So there's 2 ways of creating assemblies. We can either create the parts first and then create the assembly in a separate file, or we can contain the assembly within the parts file itself. We'll be taking the latter approach, keeping the parts and the assembly together. Once in the assembly workbench, we'll create a new assembly and you'll notice it's in bold. This is the same as the part design, it's an active assembly, so any parts will be imported into the active assembly. If we try to import these parts, it will look like they're duplicated. So let's hide each of the parts first. Now we can use the insert icon to insert components. If we was creating this assembly in a separate file, then we would use the open file to access our parts from our parts file. Here you can see each of the bodies that we can import. Let's start with the mount body. If we click on the mount body, it's added to our document and we get this message about grounded part. All assemblies have to have at least one grounded part. I'm going to select no for the time being. We can show you how to ground the parts later. We can adjust the position of the mount, but as we use the master sketch, this should be in the right position. Let's add another part, a counterweight. So we have to move this up and out the way for the time being. Next, we'll add the link body. It's in the correct direction. We'll just move this out the way. Though the assembly requires 2 of the counterweights, I haven't added them just yet. We'll come to that later. Let's hit OK for the time being. And we can drag these into position if we wanted to. But want to make the mount fix. Click on the mount. We have the toggle grounded. We just click that and that stops this from moving. Now I've got a static part. I can start constraining these parts to it. The counterweight, I want it to revolve around this hole here. We'll take the circular edge running around the outside, then come round and look at our mount. I want to select the circular edge on this side, holding down Control and select both those edges. We can see we have 2 selections on the left hand side. Come up to the top, we have our joints. One we want is our Revolute joint. So it revolves around those 2 circles. If we click that, our joint is added and we can see it on the panel on the left. Let's hit OK. So at the moment, we have one part that revolves around the mount. My next part is the link arm. We bring this around this way. We're going to add the same joint between the circles. Make sure nothing's selected and pick the joint first. On the left hand side we have the panel again. We're adding a Revolute joint, and as we hover over parts of geometry we can see we get an axis. So I want this circular edge. We just need to click on that. It gets added to the left hand side. We don't have to hold down Control. We rotate our view around and then hover over the edge of where we want to constrain to. Notice the axes are pointing in the same direction. So the Z axis is what it's going to rotate around. Select the circular edge. The link gets attached, and now we can move this up and down as well as moving the counterweight. If we pick the wrong edge, we can right click on it and remove, and then we just need to add it again. Just going to click to cancel that and hit OK. Got the first parts of our assembly attached. On the left hand side we can see the joints that have been added and also a link to the original part. At any time I can remove these parts from the assembly, and to do that we come over to tree view, click on the part that we don't want, right click and hit delete. Just going to come up to the top and click the undo. For my next part I want to import another counterweight. To do this we use the insert component and pick the counterweight again. Let's hit OK, and you may think that we need to add the same kind of constraint, the same that was applied to the counterweight, but this is unnecessary and it can cause extra load on the assembly. We just need to mirror the position of this counterweight. To do that, we use a fixed joint. First of all, let's take counterweight, click it once and then click it again. This allows us to rotate it into position, mirroring what we see here. Click off and then create the fixed joint. Let's zoom in, and I'm going to take this vertex. Look, I'm selecting this vertex here and this vertex, making sure the Z-axis, the blue lines, are in the same direction, and we click. That's brought those together as a fixed joint, but it's occupying the same space as the link. Come over to the left hand side, we have the offset, and we can move the offset, allowing us to position it in the correct position. Let's hit OK. So now what we have is a link arm, and if I move the counterweight, both counterweights move together. Now let's add the piston head. Again, we'll use the insert component. Click on piston head. That gets added. Hit OK. Zoom out slightly and manipulate the geometry just so it's pointing upwards. We want to attach the piston head in line with this hole. Now we haven't got a pin at the moment to attach this, but we don't need one. Let's take the piston head and drag it up to the top. Now inside you'll see the circular edges, and if I look from the front view, notice that we have curvature here. So these circular edges aren't on the same plane, they're actual B-splines. If I try to attach this piston head to this circular edge, which is coplanar, then we'll experience some issues. Let's take one edge, then Control select the other. Use our Revolute joint, and you notice straight away we have a problem. Let's cancel that, and with this type of scenario, we actually have to take the inner surface of that hole, and the same on this side. Control select both of those and add our Revolute joint. We could use the circular edge of the link arm, but this demonstrates surface to surface connections with a hole. Again, we'll use our offset. Offsetting the geometry to be in the middle. We have a slight problem that this is upside down. You can use the flip. And if we look from, say, the right, we can use the seam and place this in the position that we want. Let's hit OK. So now we have piston head, the link arm, and the counterweight, but there is a problem. This rotates correctly, but we want to keep the motion vertical. So if I create a rotation here, see this is not really working as it should. So how do we solve this? Let's look at the top surface of the piston head. I want to keep this in line with something, some kind of part, but allow it to slide up and down. We have the sliding joint. If we click that, then I hover over the top, we can see Z-axis is running downwards. That's let the top of the piston. That's come down to the bottom. And we see the Z-axis for this face is running in the same direction. Let's click that. So now we've aligned these two faces. Let's hit OK. If we click and drag the counterweight, rotating it, all other parts will follow, fully simulating the mechanical movement. But this is a manual process. In the next section, you'll be introduced to a new feature in FreeCAD 1.1, the assembly simulation tool, where we'll simulate and animate the mechanical movement. The simulation adds motion to joints, the same way as we've been manipulating the counterweight. Make sure our assembly is active, because at the moment it's not in bold. And if I look at the joints, it's going to hide the grounded joint. And if I move this counterweight here, we can see the joint becoming active between the counterweight and the mount. If I come over to the Revolute joint and click on it, I can see the parts that are not transparent are under constraint by that joint. The simulation adds a motion to this joint. Create a simulation. Best to first rename the joint that we want to manipulate. In this case, the Revolute. Let's rename this and let's try that again and set it to counterweight, Revolute. The joint is named, so when we create a new simulation via the button in the toolbar or assembly and simulate, we can start adding the motion. If we click on the plus icon, we can add a joint. And straight away we can see we've got our counterweight Revolute. The motion type, we've only got one. Let's select that. The formula can be changed. Default is 5 multiplied by the time. Let's set this to 1 and hit OK. So we've added the joint. Next comes the simulation settings. And this is the duration of the start and end, along with a multiplier step. At the moment, the start and the end are set to 0 and 1. Step is 0.01. When I hit generate, we get the animation player. And we see the frames start from 0 all the way 101. And this is because of the step. If I change this step 1 and generate, we only get 2 frames. Animation cycle. This is a cycle of animation. Anything above the animation player, the start, end, step, and tolerance, including the joints and formulas within, if those change, then we need hit generate. The frames per second, we don't. Let's set the start from 0 and the end 60. If we hit generate now, because of the step is set to 1, we get frames from 0 all the way to 61. At frames per second of 30, this is going to be quite choppy. There's 2 things we can do. We can decrease the step, say 0.1. That will increase the amount of frames that's generated from the start and the end. So we just have to be a bit wary of that, because FreeCAD will take longer generate those frames. Or we can come up to the motions and change the formula. We'll set this to 0.1 multiplied by time. Yeah, okay. We hit generate now and hit play. We get a much smoother animation. And if I stop this and set this to 60 and hit play, we can increase the amount of frames per second, increasing the speed of the animation. So at the moment we have a full cycle. If we look, we've got a distinct pause in there. So I want continuous animation of this counterweight. We could spend the time trying to synchronize the frames with the rotation, but there is an easier way. Let's come back to the motions. Double click on that and look at the formula. We can use the maths constant in here, pi. So for the formula, let's type in 2 multiplied by pi multiplied by time and hit OK. The start and the end, I'm just going to change this back to the defaults. And the step 0.01. And we hit generate. We've got 101 frames. Let's lower the frames per second. 30. Back to the default. If I hit play now, you'll notice we won't get that step in here, that pause. It's continuous animation. Let's increase that to 60. Hit play. So we get a continuous animation of the counterweight. Again, we can change the formula, say 4 times pi. Regenerate and hit play. Therefore, we're getting 2 rotations for each cycle of animation. You may experience that your animation breaks and you'll find one of your parts that's connected with a joint is misaligned or somewhere off in space. If that happens, cancel the simulation and then reapply it. Final note is that the smoothness of the animation depends on your CPU performance and how complex the assembly is. The more linked joints involved in the simulation, the higher the load on the CPU. You may need to fine-tune these settings, balance the performance and smoothness of the animation. Hope you enjoyed that lesson, and I hope to see you in the next one. If you like what you see and you want to donate to the channel, then you can do so via Ko-Fi or Ko-Fi at ko-fi.com/MANG0 or via PayPal at paypal.com/paypalme/DarrenBEstone. I also run a Patreon where you can get early access and additional content, and that's at patreon.com/MangoJellySolutions. Links can be found in the channel header, on the About page, or in the descriptions of these videos. I thank everybody that's donated so far. It really helps to keep the lights on so I can produce more content and also expand the channel. Thank you for liking, commenting and subscribing to these videos, and I hope to see you again in the next one.